So this class is about electric field. So we all know what is a charge. So consider a charge Q which is placed in vacuum. So consider a charge Q, and let me say this charge is placed in vacuum. Now we know that if you bring another positive charge Q, so let us say this charge Q is at a distance r from this Q. So now if you place another charge small q at a distance r from Q, we know that this charge small q will experience a force, and this force is given by 1 by 4 pi epsilon naught q into q by r square. So now remove this small q. So in the vacuum, so q is there, so remove q. So is there anything left out in vacuum now? So in the vacuum we have a charge q, so is there anything left out? So after removing small q, so to explain this we introduce the concept of field. So we introduce the concept of field. We say that there is some electric field surrounding the charge q. So there exists an electric field surrounding this charge q, and this is because of this electric field only there was a force. So now we can say that electric field is nothing but the region surrounding the charge q where one can experience electrostatic force. So let us define the electric field. The region surrounding a charge q, the region surrounding a charge q in which a test charge small q can experience a force. So the region surrounding a charge is called as electric field. So how do we measure this electric field? The electric field produced by the charge q at point r is given by electric field produced by charge q at a distance r is given by E is equal to F by Q. So we know that F in the previous case it was 1 by 4 pi epsilon naught into Q multiplied by small q by r square. So this electric field is given by 1 by 4 pi epsilon naught into Q divided by r square. So it is a vector quantity, so multiplied by unit vector r. So electric field is a vector quantity. So its unit is, so from this we can say force is in Newton and charge is in Coulomb. So the electric field has a unit of Newton per Coulomb. So E equal to FQ, or we can write F is equal to E into Q. So the electric field E is equal to F into Q, or F force is equal to E into Q. So now let us do one derivation. So we'll see electric field due to a point charge. Electric field due to a point charge. So consider a charge Q. So charge Q placed at O. So consider a charge Q placed at O, and consider another test charge plus Q placed at a distance R from O. So because these two are like charges, they repel each other, so there exists a force. So the force is because of electric field. So now we will find out what is the electric field at point A. Let me write this point as A, where plus Q charge is placed. So by Coulomb's law we have the force is 1 by 4 pi epsilon naught Q into Q divided by R square into unit vector R. So force, so if I do electric field, so it is nothing but F by Q, or I can write F by Q, force per unit charge, is 1 by 4 pi epsilon naught into Q by Q R square into Q to R. So this small q will get cancelled. So force per unit charge is nothing but electric field. So this is nothing but electric field E equal to 1 by 4 pi epsilon naught into Q divided by R square to unit vector R. So this gives the electric field intensity at a point A due to charge Q. So this is nothing but electric field at point A due to charge Q. Electric field at point A due to charge Q. Point P A is at a distance R from Q. Point A is at a distance small r from Q. So using this formula we can find out the electric field at any point r. At any point A, which is at a distance r from the source charge Q. So the electric field intensity is inversely proportional to the square of the distance the electric field intensity is directed. So I can mark here the field intensity E. So this is E. So it will be acting along the force F. So the force is acting like this. So the field is also in the same direction. So the electric field intensity or electric field is a vector quantity, and at any point it is directed in the direction of the force. So electric field is a vector quantity. So in this derivation, from this derivation we can calculate the electric field due to a point charge capital Q at a distance r from it. So if your source charge Q is greater than 0, then the electric field is directed away from it. So as in this case, so I have shown here the forces and the electric field are going towards right. That means if Q is greater than 0, then E is directed away from it. So if Q is less than 0, then E is directed towards it. So in this case we can write, so Q is greater than 0. So if it is plus Q, so and if this is small q, so the field will be directed away from it. Similarly, if this is minus q and this is q, then field will be directed towards it. Because the force is attractive force, so the field is always directed along the force itself. So remember the SI unit also. So electric field is easily calculated as F by Q.